Welcome to the Talon Talks podcast from Embry-Riddle Aeronautical University. I'm Alan Caesar. My guest today is Stephanie Miller. She's Executive Director of Technology Transfer and Research Park Initiatives, which means she manages operations at the Embry-Riddle Research Park, including the Micaplex Technology Business Incubator. She got a Ph.D. in biochemistry and molecular genetics from University of Virginia in 2009 and a master's in business administration from Embry-Riddle in 2018. Stephanie, thanks for joining me today.
Happy to be here. Thanks for asking me to join the podcast.
All right. So this is a bit risky, but I kind of want to jump right into the deep end here, and maybe we'll be able to swim back to the edge, or maybe I'll be able to swim back to the edge. I'm sure you'll be fine. I saw that your doctoral dissertation was an analysis of, I'm probably pronouncing this wrong, kinetochore microtubule interactions mediated by NDC80 complex and its role in cancer progression. Now, I understand the words cancer progression, and I can kind of picture what microtubules might be, but I'm curious about what all the rest of that means because it goes way over my head, but it sounds super interesting.
Yeah, well, actually, you pronounced every word correctly, so kudos for that, because most people mess up at least one of those technical terms. But yeah, the work that I did in grad school is obviously very different from my job now. But basically, what I was researching in graduate school was cell division, how one cell in your body duplicates its chromosomes and then splits into two cells that are exact copies of each other. And when that goes right, that's a great thing. That's how a lot of your tissues in your body regenerate or replenish. It's how wound healing happens, things like that. But when it goes wrong, that's when you can get cancer formation or some other types of diseases as well. So basically, in a nutshell, what I was researching is one tiny, tiny piece of the machinery that makes sure those chromosomes get pulled into each daughter cell faithfully. Because when that goes wrong, you might get cancer. And so the hypothesis was that if we can figure out how it mechanically does this correctly, then we might be able to identify mistakes that lead to cancer progression.
So the mechanical sorts of parts of the cells that you're referring to, I kind of vaguely remember some diagrams from biology class. They're sort of like, are they like T-shaped things that kind of pull at the thing, or what are those pieces called?
Yeah, if anyone remembers their intro to biology class in college, or even biology class in high school, you would see this idea of mitosis. So you go through the different phases of it, and the microtubules themselves kind of look like a football shape. So there are ends where at each side of the cell, and these microtubules emanate from the ends into the center where the chromosomes are sitting. And they mechanically attach and then pull them apart.
Interesting. And so what is it in that pulling apart? What role do they play then in causing cancer and something going wrong in the...
Right. So you want to obviously separate one copy of each chromosome, and humans have 46 of them. You want to separate one copy into each cell, because if you get two copies, or if a chromosome breaks, or somehow or another is not faithfully duplicated, you can have problems. So those microtubules, and you can really imagine them as ropes that are coming out and attaching to these chromosomes. They need to not only attach correctly, but one from the left side needs to attach to one chromosome pair. One from the right side needs to attach to a duplicate and pull them apart. And there's some really interesting and honestly not so well understood mechanisms that your cell knows if it's done this correctly or not, and will actually halt cell division if they are not properly attached.
All right. So I'm picturing the double helix chromosome, and the thing is like grabbing sort of at the end and like pulling it apart like a zipper.
Not so much. Think of the chromosomes that you might have seen in pictures that look like an X.
Oh, okay.
Yeah. So one side of that X is one copy. One side of the X is another, and they're held together in the middle to make that X shape. And so the microtubules come out, attach to it, and pull that X into two pieces.
Gotcha.
Yeah.
That's really cool. So what's it feel like to be involved in research like that? Does it seem important at the time that you're doing it, or is it a slog until like you actually publish and you feel like, that sort of moment of satisfaction?
Yeah, exactly. It can be a bit of both. When you're doing research, especially biomedical research, which is what I have most my experience in, you can do experiment after experiment, and they might fail or you fail to repeat the results of a previous experiment, or you haven't designed it correctly to get the answers that you want. So there were times where I very much felt like almost a factory worker. I'm doing this experiment, the same motions over and over, trying to get a meaningful result. And sometimes it's just until, the confluence of events where you've designed it correctly, you've got everything in the right concentrations and mixtures, and you get some data that you can interpret, and then you do it again and it comes back with a similar or same result, and it gives you more faith in the results. So once that happens, it's very exciting because now you've discovered something that no one has ever discovered before. That's the cool thing about research is you are really at the edge of human knowledge, and that's very exciting. But leading up to it can be a little bit demoralizing, and you're not quite sure what you're doing until it just works.
Yeah, yeah. So you're at the very edge of human knowledge. The generally technology that's generally out in industry is several steps back from that edge. I'm wondering if did anything that you work on did you have an immediate sense of where that was going in terms of the practical applications in the industry, or was it more pure research?
I would definitely consider it more pure research, but some of the work I did was able to define a potential drug target. I didn't do any drug screening or anything like that, but the information that I put out there through my publications, it's feasible that a pharmaceutical company could take that work and decide they want to target the particular protein I was working on and try to find a new cancer drug from that. To my knowledge, no one's done that yet. It's just a potential result of it. But I would definitely consider the work that I did to be what's called more basic research, just adding to the field, adding to human knowledge. And someone may take that further into something that would be a therapeutic someday.
So switching gears then to what you do now, is it technology transfer, as I understand it, is sort of taking academic research and moving it to the realm of products for use out in the world? Can you tell me more about what that sort of process is, or how that works?
Sure. So let me tell you first how I got into it, because I think it makes a little more sense. When people hear about my research background and then what I do today, there's some disconnect there. And the way that I got into tech transfer was finishing up grad school. I wasn't confident that I wanted to go work for industry and do biomedical research in a lab for my entire career. So I was looking around for different options and ended up doing an internship in the University of Virginia's Patent Foundation, now called the Licensing and Ventures Group. And that's the tech transfer office for UVA. And basically what any tech transfer office does at a university is takes the research results, things that are invented or software that is written at a university, appropriately protect the intellectual property, which means filing patent applications or copyright registrations, and then seeks to market that to industry so that they can further that discovery to the point where it's a product that can go on the market. So the process of tech transfer really involves a lot of different disciplines, from the technical side of the invention, patent law and working with patent attorneys, marketing so that you can find the right company that's interested in this technology, and then also a bit of negotiation and legal work to get to an agreement that lays out what they're getting, what they're giving in return, what their plans are. So that whole process can take a decent amount of time, and it's something that I find really rewarding because you're doing different things all the time.
So the reason that this sort of exists is because you want to keep the professors focused on doing their research, and somebody else has to jump through the legal hurdles and do these negotiations. Is that kind of the idea?
Partly, but also because there needs to be a mechanism to get things out there. A lot of research that's done is funded by the government, so taxpayer money. And it's great if you're doing research like I did and you're furthering human knowledge. But a lot of things, for instance, that we do at Embry-Riddle, that research is very applied and is very close to a real world product. And we want to get that out there and have it, made as something that can benefit the public, because basically they've paid for it by their tax dollars investing in the grants that we receive to do research.
So you're now also an adjunct professor teaching entrepreneurship. Are there lessons that you see that you take from seeing companies trying to get this technology to market that you bring to your students in your class?
Yeah, definitely. We try to use case studies, real world case studies, to show them, one, the importance of intellectual property and how businesses use it to gain an advantage in the market, but also just talk to them about how companies take an idea from conception through protection, through development, through final manufacturing and distribution. Knowing how companies do that is very helpful for these entrepreneurs to think about the entire chain of events that would have to happen to go from their idea to something on the shelves or being sold to Boeing or something like that.
What's a common mistake that you maybe have seen businesses and startups make in trying to move their technologies to market?
I think the biggest mistake that I've seen is that, and I say this very nicely, people don't know what they don't know. So a lot of times you have engineers or people with technical backgrounds that are amazing at what they do and come up with brilliant inventions. But building a company around that invention so that you can actually bring it to market, have a viable company that's profitable and can continue, that's a whole new set of skills that they probably have not had to worry about before. Maybe have not had taken business classes or understand some of the jargon that's used. So getting people to change their mindset a little bit from the straight product development and engineering that goes along with that into how am I going to convince investors that this will sell? That's a big change that entrepreneurs have to make in their mind to be successful. And it can be a bit of a hurdle, but that's part of what we do in the incubator is help them out to figure out what it is they don't know.
Yeah. Do you ever get somebody who's like really gung ho and thinks they've got, the world's next best thing and they're just not developed enough yet?
Oh, of course. You always run across people like that. And actually that's part of our screening process for the incubator. There is an application process. We do meet with them several times. And one of the things that we look for is a founder or a team of founders that's coachable, that's interested in learning, that wants to talk with mentors and is willing to take their expertise and advice and bring that into their own company. It's really important because no one knows everything.
Right. Well, so I didn't realize that you've got a sort of a mentorship program built into the incubator.
Yeah, we take a very personalized approach to the incubator. We're pretty small. We only have a handful of companies at any one time that are a part of the incubator. And while we do run some, scripted programs, most of what we do is a very tailored approach to each startup company because they might be in different phases. They might have different needs. One might just be starting up and need some legal help with incorporation or with filing a patent application. And another might be to the point where they're having to write up pro formas and they need an accountant or some other service like that. So I meet with the CEOs of these companies as often as possible and just let them talk. Tell me where you are, what you're doing, what you need. And maybe I hear something that they don't know that they need and I can connect them to the right resource at the right time.
That's great. You came here to work at a research park. You also got an MBA while you've been working here. First of all, is that hard to do? Like to get your MBA while you're working a full-time job?
Well, I definitely did it part-time. I took one class per semester. I did try taking 2 classes one semester. That was the hardest semester of my life. It's not easy, but if you're doing one at a time, obviously it took a lot longer. It took me 4.5 years to finish what is a 18 to 24 month program. But that allowed me to keep my sanity, be able to do my full-time job. And in the end, it was totally worth it to take the longer route to really get the most value out of it.
I'm curious, did you go through the worldwide campus and do it all online, or did you go to the Daytona Beach campus college business there?
Yeah, the majority of my classes were on campus in Daytona Beach. There were 2 classes that were only offered through Worldwide that I was really interested in taking. So they do allow you to take a certain percentage or number of classes online instead of residential. But yeah, most of them were right here in Daytona.
So how did you get from your office to the campus there? Because you have to go past the airport, but parking can be kind of tough. So did you walk? Do you have a scooter? I have a scooter.
Well,
so
actually, when I started my MBA, I was in the Lehman building, the College of Engineering.
Oh,
that was before the research park was even built. So I could just walk across campus at that time. And then, yeah, once I was over here, I still had a couple classes left. And, I just make sure I drove over well before the previous class let out, try to find a parking spot before everyone else coming in. It can be a challenge for sure.
So why did you feel like you could benefit from an MBA at that point?
Well, originally my reason for getting the MBA was the technology transfer aspect of my job. The research park was not part of it at that point. And my rationale behind it was, I've always worked at universities. I've always been on, I guess, the selling side of technology. But what I wanted to understand is these companies that I'm marketing to, what are their considerations internally when they decide they have interest, they might license, what they're willing to accept as far as financial terms. I wanted to get a little more inside their head and understand how they approach this opportunity so that I could be better at marketing it, selling it, negotiating agreements.
Well, so now I don't have a master's degree, but I've tried going back for like a second bachelor's, and I found that some of the course content in like a physics class, I was like way overthinking one of the problems. I remember like banging my head against the wall for like an hour. I called up like an engineer friend of mine. I called up a mathematician friend of mine to help me figure out this one problem. Like we tried throwing calculus at it. I made sure my calculator was in radians. Like one of them was like, well, maybe we should do a Laplace transform. I'm like, no, this isn't a Laplace transform. This is, physics 2 or whatever. And I eventually found out that it was the problem was literally the 2 trains coming at each other on a track at different speeds, and when do they crash. It was basically that, but like with light waves. It was a really, really simple problem. So I'm wondering that, was it hard for you to were there challenges like that or other kind of challenges that you didn't expect going into a master's program again after having done a doctorate?
Well, MBA programs typically are designed for people that have some work experience and are going back to school to, fill in any gaps, things like that. I'll tell you the one intimidating thing about going back to school is that you are the oldest person in the classroom. Because a lot of our students continue after their bachelor's to get their master's. One of them mistook me for the professor, which I was also a professor at the time, so that's not too far of a stretch. But I was definitely considered one of the wiser people in the room when I was taking classes.
Well, that's great. So you were telling us that you started to get into sewing a bit since the pandemic. Can you tell me a little bit about what you've been doing and your interest in sewing machines?
Yeah. I've known how to sew for a long time. And obviously when this all hit, the idea of getting masks, they weren't being sold everywhere yet. I said, I'm going to get out my old Singer sewing machine and make myself some masks. And around the same time, a friend of mine had found one in a storage locker that he had bought and said, oh, this might be good decoration. It doesn't work. It's all rusty and everything. I ended up getting that working, got it cleaned up. It's actually over 100 years old, and now it sews like it was new. So that began my vintage sewing machine journey. And I said I wasn't going to be a collector when I got that first one, but then sometimes they come up on Facebook Marketplace and it's a good deal. And, you can get one for say 10 or $20 that people think is only good for a lawn ornament. but you put a little work into them and they work again. So I'm now up to over a dozen. Not all of them work. Not all of them have been cleaned up and gotten running. I haven't gotten them running yet, but it's a new hobby that I picked up this year, and it's been a lot of fun.
So, are you a fairly handy person?
Yeah, I'd say so. My father was a mechanic on motorcycles, cars, and airplanes. He was in the Air Force. He was an aircraft mechanic for a while. So I was working with him in the garage when I was, a little kid, 6, 7, 8 years old, showing me how to change the oil. We bought my first car out of a junkyard, put a whole new engine in it for when I turned 16. So I also work on cars a lot. I've got a few cars. I like to play with those.
Yeah, now you got to tell me what cars you like to play with.
Well, my everyday driver is a Mini Cooper, which is really cute, but I don't work on it too much because it's brand new cars are kind of hard to work on. You've got to remove 20 parts to get to the oil filter. Mm-hmm. But I have my baby is my 1977 Plymouth Roadrunner, which I got I got it when I was, I think 19 years old in college. It was to replace the 1976 Roadrunner that I had crashed into a tree. So now I have a 77, a year newer. I used to deliver pizza in that car. I drag raced that car. I used to race it. And now it's retired. It's in Florida and it's retirement and is my kind of Sunday driver.
Right on. So delivering pizzas, I mean, the fuel costs on that must have eaten into your income a little bit.
Well, this was quite a long time ago. Gas wasn't quite as expensive as it is now.
That's fair. That's fair. I love all these details. I really appreciate it. We'll continue to the lightning round after this brief message. The Embry-Riddle Alumni Engagement Team has been hard at work the last few months updating your alumni website. The redesigned site has a new look and layout, making it easier to find all the ways you can continue to benefit and give back to your alma mater. Explore the new alumni.erau.edu and send us your feedback. We're always looking for better ways to serve our loyal alumni. Thank you for being forever an Eagle. Now, it's time for the lightning round. Are you ready?
I'm not sure, but let's give it a try.
All right. So if you, since you're into vintage sewing machines, if you could get any sewing machine ever made, what would it be? Do you have sort of a dream model?
I do. Right now, I'm looking for a Singer 301 Centennial Edition. So a lot of people, when they think of the vintage Singers, it's that classic kind of look to an old sewing machine, and they were always made in the color black. In the 50s, they started making them tan and some other colors. So it is the last time they made a black sewing machine. I am a fan. I always am pretty much dressed in black. A lot of my decorations are also black. So that's one I would really love to have someday.
Is the Centennial Edition, was that made in like 2000 or is it earlier than that?
Oh no, this was made back in the 50s.
Okay. I didn't know if it was called the Centennial Edition because they like brought it back in 2000 or something, but legit vintage black one.
Yeah.
Right on. If you could read only one book for the rest of your life, what would it be?
I think if I could read one book for the rest of my life, it's going to be one from, I guess, my later childhood, a book called Watership Down.
Yeah. That's the rabbits, right?
Yeah. And what's funny is when you tell people that, they're like, oh, it's the book about the rabbits, right?
Right.
What's really interesting to me, as good as a kid, when you read it when you're older, there's a lot of themes about society and religion that are in there as well that you come to appreciate as an adult. And one thing that's not in my bio that I gave you, I have a minor in religious studies. So that some of the themes in that book really became interesting to me once I took some courses in college about religion.
Yeah, well, there was definitely one of the is it a Warren? Is that what the rabbit sort of?
Yeah.
Okay. Yeah, I remember one of them. It was like very much like an authoritarian kind of cult. That was
through their travels, they come across different ones that have different styles of leadership and society, and it's very much an allegory for people, but it's rabbits.
Yeah, it was a really interesting book. So who's your favorite cartoon character?
The Roadrunner.
Yeah. Well, there you go. There you go. Oh yeah, I wanted to ask you that none of your Roadrunners have been Superbirds, have they?
No, I have not had a Superbird, just the regular Roadrunners.
Okay. Yeah. So, all right. So picture for me your ideal grilled cheese sandwich. You got it in your hands. You're about to take a bite out of this thing. What are you about to sink your teeth into?
It's definitely got to have bacon on it. Everything's better with bacon. I would say a grilled cheese, maybe sourdough bread, cheese and bacon. That'd be perfect.
What kind of cheese do you use?
Probably just your plain old cheddar.
Yeah. All right. If you could live for a week as any person in history, who would it be?
So I do a lot of reading about historical figures, and I did a really in-depth report actually for one of my MBA classes about leadership, about Catherine de' Medici, who was in Italy in the, it's been a while since I did this, 13th, 14th, 15th century, somewhere in there. But she was a basically woman behind the scenes in charge of this powerful family. The men were often the face of the family, but a lot of the dealings of the family and their bank really came from ideas from her, and she kind of kept everything together. I think it would be really interesting to live her life for a week, not only in the historical context of what life was like back then. Certainly don't want to stay there forever, but to see what it's like to be a woman at a time where you are not really allowed to be a leader.
Yeah. All right. Well, thanks very much, Stephanie, for joining us for the Talon Talks podcast.
Happy to. Thanks for inviting me on. This was fun.
All right. Talon Talks is a production of Wicked Radio and the Embry-Riddle Office of Philanthropy and Alumni Engagement. We're coming at you from my office at Embry-Riddle Aeronautical University in Daytona Beach, Florida, and Stephanie's office also here at Embry-Riddle in Daytona. This episode was recorded by me. Edmund Odarte is our program manager. Bill Thompson is executive director of alumni engagement, and Tony Brown is executive director of communications. If you'd like to share your thoughts about our show or suggest a guest to us, we'd love to hear from you. Visit alumni.erau.edu/podcast and click the feedback link. I promise your message comes directly to me. Thanks for downloading us. We'll see you next time.